And hello, my name is Kristoff Finley. I'm doing this project with Riley Williams. This is the project 3 for networks. I just wanted to show you our program running and also the output. I'm going to pull up in the terminal here just to show you that it all works, and then we'll go through the code. So first, I'm gonna run the network, so that's listening, and then I'm going to run the simulation. The simulation will send packets to the network, as you will see, and I'll just make this input bigger, the screen bigger, so you can see what's going on. So it sends the packets. I have it sending every 1 second. I can scroll up on the input after it sends everything. As you notice, it sends all 8 packets, and then it also follows the rules. So I'll just scroll up slowly in case you want to pause the video and check to make sure it's sending all right. Our output, I'd say, matches Reese's 99%, and all the rules are being kind of followed by the network, and the routers are distributing the packets amongst themselves, which is awesome. I'm going to show you the code and how that's all working right now. And here we go. So I'm going to close the terminal now. So first of all, we have simulation. This is the thing that's going to send the packets over the network. So as you can see, I have a port number, a host number, and then, but before I do any of that, I actually need to parse the packets from these CSVs right here. So we do that here, and there's a similar logic with the routers and also the rules, which I can show you in a second here. So essentially, I parse the packets, and then we're going to send it over the network, and this is going to be TCP. I'm just using the Python socket library, which is awesome. I basically say for peeing my packets, these are the ones I parsed earlier, send it over the network, and then wait 1 second. Pretty simple. Next, we'll look at the network, which is kind of the other big class, and then we can look at the data structures if you're interested. So this one also obviously connects to the same port, the same host. I have a packet count, so I know when to stop carrying. Basically, I bind to the socket, and then after I do that, I'm officially listening, and I accept one connection, and that will be from the simulation, and then I get the packet. This pickle.loads basically deserializes the packet that I sent over the network with pickle, and then I can actually do stuff with it. I also forgot to mention that we parse the routers here also. Right here is where basically all the data from these files, the CSVs, are put into data structures. Sorry, I forgot to mention that. Anyways, so the meat of this logic comes in this handle packet, and we just put that in. We put that right here, and it's actually in receive. So every router can receive a packet, and it does different things depending on what the rules of the router is. So we're just going to look at router here. So first of all, we have the data structure. There's the class router, kind of basic stuff, getters and setters, and then we have receive. So this was that method, the method that I just pointed out. Basically, we receive the packet, and we look if it's the correct destination IP. If it is, okay, we're done. We don't need to evaluate any more rules. Otherwise, we're going to check the rules of the router. So what we do is we get the rules here. We actually did some parsing here as well. And then we separated the rule into two different areas. I'm going to click over to rules here to show you. So in rules, you'll notice that we have the action we're doing, and then we have the condition. So the condition is separated into 2 parts, and the action is just 1 part. So anyways, there's 3 different distinct parts, so that's what we're parsing here. We have the action, the condition, and then the condition variable and condition value. So action, variable, and then the value. So that's what we're doing here. We're basically seeing what the action is, and then we're seeing these lines right here are saying, okay, does our packets match this condition? And if it does, we're going to execute the rule. Execute the rule is this one up here. We say, okay, we found the rule, great. And then what we do is we look at which action we're doing for the rule, and based on the one we do, we have a forward, modify, and a drop methods as well. And I'll just scroll down here. These are what those methods look like. Pretty simple. If it's B, do everything again, except do it with router B. We have a router list, so when we parse the routers in, I'll show you the router data structure. Actually, I just showed you. When we parse the routers in, we make a router list. Router B would be the first index because it goes A, B, C, D. So we're going to say, okay, let router B handle this, and we're going to let router B receive it, and then we kind of do this until we either match on a rule, meaning a rule is telling us to drop or something like that, or no rules are applicable, or it's the IP is in the subnet. So yeah, and then this was what modify looks like. It basically just changes the value of the packet, and we just have the router kind of receiving that packet again to evaluate it. Awesome. At a high level, let's go back to network here. After the packet is handled, we move on to the next packet, and then we check if we've kind of evaluated all the packets. And once that's done, we finish the program. Yeah, I believe I showed. Oh, I'll just show you the packet class really quick. Super simple. Yeah. Now that I showed you all the code and it running, this is Riley and myself's Project 3 submission for networks. Thank you for listening. Have a great day.